Hello, my name is Imran, and today we're going to talk about the 6-bar lift for Vex Robotics. My team is 2777T, and this was also my first year in robotics this year. We did pretty good overall. First, we're going to talk about how the 6-bar works and why would you want a 6-bar lift for your robot. How a 6-bar works is you have this motor on the left side and the right side. The motor powers C channels, and the C channels lift to maximum height. Why would you want it? One reason is it can reach pretty high, and another is this 2x1 C channel, and this 2x1 C channel stays vertical the whole time, no matter what, if you have it screwed in the right place. As you can see, I'll show you. Completely vertical, no matter what. But if you have it plugged in the wrong hole, that I can show you in just a minute, put it in a different hole, and I lift it, you can see this 2x1 C channel is no longer vertical, but the one in the back is. So where you put your hole is very important. You have to get it right if you want your lift to work correctly. And as you can see, even as it's down, it's not looking correct. Now that I put it back in the hole, it's fine. We're going to talk about gears and gear ratios. For this robot, I'm using a 5:1 gear ratio, a 12-tooth metal gear, and a 60-tooth plastic gear. It is a 5:1 because for every 5 times this metal gear turns, this blue one, this green gear turns 1 time. So this is driving, this is a driven, 5:1. Back here, when you're putting your lift on, you'd want equal spaces. As you can see, let me show you real quick. The end of your C channels where your gear that's connected to your gear, and the top longer portion needs to be aligned correctly. And you want to use collars, spacers, axles, and motors. While we're back here, let's talk about this plastic piece right here. This one right here that's going across. Why would you need this? The reason I have this on here is to prevent from coming out or not staying properly parallel. Because if this right here comes off, like let's just say they're like inwards. Without this, then my lift's not going to lift properly because these have to stay upright the whole time. Alright. Same, I have this piece right here too, in the front. This piece right here, it can go down here, it can go up here, whatever works for you. This right here is to prevent, it keeps the lift just about parallel. See, when you lift, you want it to be parallel as much as you can get it, no matter what. See right here, as you can see, you don't want your intake to be like this. These go up right, almost at the same time, come down almost at the same time, and that's how you want your that's why you'd want this piece right here. How the 6-bar works is the motor turns the 12 teeth, which turns the green 60 teeth gear, and that lifts this bottom. Since my 60 tooth is connected to this bottom 2x1 C channel, this is the powerhouse for the lift. On the left side, on the right side, and the left side, this right here lifts the whole robot. So for my programming, I had it with one button would lift and lower the lift. So as this would lift, this goes to maximum height. As you can see, it's parallel, it's at maximum height. The reason you have this right here is the powerhouse, as I mentioned earlier. This right here is to extend your 6 bars to its maximum height as you want it to be. And this right here, this top portion, is to place something. Your intake would be right here. So right here you would put your intake and your conveyor system right here, and it would be vertical the whole time. So as you can see, as these come down again, as these C channels are facing downwards, your intake or conveyor system would still be vertical, and that's the advantage of the 6-bar lift. If you use a 7-to-1 gear ratio, it's going to give you more torque, which means you can lift more weight, but it's going to make it slower, and 5-to-1 is absolutely fine. I had no problem with it. As you can see in the back, I only have 2 motors, a left side and a right side. And the reason being is this is just a prototype for your actual robot competition. You'd want to use, if you have the heavy metal, also known as steel, you'd want to have 4 motors. So you would have another motor down here with a 12-tooth plastic gear programmed correctly. Or you could use aluminum. For my competition robot, I first had steel and I had 4 robots, then I converted over to aluminum. And I still use 4 just to be sure my lift never gave out. The advantage of the aluminum is it's lighter, a lot lighter. It's less than half, but it's more expensive, so not everybody has it. So if you don't have it, you can just have 4 motors, and they'll work perfectly fine. Alrighty, just put something else here. As mentioned here, as you can see, I'm using a lock nut right here, and you'd want to use a lock nut. So if you use a regular Kepler nut, you would tighten it up, or you're not supposed to tighten it up all the way because you want it to be a little loose, so your 6-bar can go up and down. Let's say use the normal Kepler nut. Then what would happen is, if you have it too tight, your lift is not going to go up or down, and if it's too loose, it's going to fall right off. So this is why I recommend you use a lock nut. So I got this. How intake would work if it was went on its own. As you can see, each bar, this is how it goes up when it doesn't have that connected. For your actual robot, let's say you have your lift coming down and it's coming like this. One's faster than the other. That could cost you the game. It could cause game objects to come out your lift, which you would not want. So this is why it is recommended to have a piece right here. If you have to, you can put it down here. Whatever keeps these almost aligned. You still want some twist in it, but not too much. That's about it. I hope this video helps you, and thank you for watching.